We're now going to do section 5.2, which is integrals involving the natural log. So if we remember from the last section, the derivative of the natural log of x was 1 over x, and the derivative of the natural log of u was u prime over u. Well, if we remember, derivatives and integrals are opposite operations of each other. So instead of the derivative of the natural log of x being 1 over x, I'm going to go backwards and say the integral of 1 over x dx equals the natural log of the absolute value of x plus c. And for the second one, where the derivative of the natural log of x equals u prime over u, the integral of u prime over u du is going to equal the natural log of the absolute value of u plus c. All right, so let's go ahead and apply this to some problems. So number 1, the integral of 4 over x dx. Well, first, I can take that 4 out front. Any constants we can take out front. So I'm left with the integral of 1 over x dx. Well, this is nice. Leave my 4 out front. The integral of 1 over x dx is the natural log of the absolute value of x plus c. But remember, with our logs, any constants out front can become exponents. So I get the natural log of the absolute value of x to the 4th plus c. So this is the answer I'm looking for. Let's do another one. So number 2. The integral of 1 over 2x plus 5 dx. All right, so as I've said before, there's no such thing as quotient rule or product rule for integrals. So we have to do something else. Whenever you have a fraction, you will probably be doing integration by substitution and be doing this logarithmic rule. So when we do this, you're going to choose your denominator to be u. So u is 2x plus 5. Then find the derivative of that. U prime is 2. Or I'm going to call that du dx. Du dx and u prime are the same thing. So I get du equals 2 dx. So my integral then becomes the integral of, my denominator is u. All I have left in my problem, though, is 1 dx. I need that to match up exactly with what's over here. It doesn't. I have 2 dx. So I need to get rid of the 2. I'm going to divide each side by 2. So I'm going to do 1/2 du equals dx. So now I can get rid of the dx in my problem up here and replace it with 1/2 du. Because 1/2 is a constant, it can go out front. Whenever we have a constant, we can put it out front. Because there is nothing left on the numerator, we put a 1 there. And now we can integrate it. So the integral of 1 over u du, leave the 1/2 out front, is going to be the natural log of the absolute value of u plus c. Plug your information back in. So I have 1/2 the natural log of the absolute value of u. Remember, 2x plus 5 is equal to u. So this is going to become 2x plus 5, then plus c. But again, remember that 1/2 can become an exponent. So I get the natural log of the absolute value of 2x plus 5 to the 1/2 power plus c. But remember, 1/2 power means square root. So I get the natural log of the square root of 2x, of the absolute value of 2x plus 5, then plus c. So that's what I'm looking for. So we're doing integrals by use substitution and using logs in them also. So logs come into play when we have fractions. All right, let's do another one. Number 3. The integral of x over x squared plus 1 dx. All right, because it's a fraction, I'm going to typically choose my denominator to be u, which is going to be x squared plus 1. So then du dx would be 2x. I always like to get du by itself. So 2x dx is du. So my function becomes, my integral becomes u in the denominator. What I have left is x dx. That's what I have left. That has to match up exactly with what's over here. It does not currently, so I need to make it match. So what I'm going to do is divide each side by 2. So I get 1/2 du equals x dx. And now it matches up exactly. So I can get rid of my x dx and put in 1/2 du. There's nothing left in the numerator, so I just put a 1 there. When this happens, you should get a very nice little integral that you can integrate very quickly. All right, so now that I have that, I can integrate it very quickly. Leave the 1/2 out front. The integral of 1 over u du is the natural log of the absolute value of u plus c. Put your information back in. So I get 1/2 the natural log of the absolute value of u. Go back up and look, u is x squared plus 1. So that's what goes in here, plus c. But again, I don't like the 1/2 out front. 1/2 becomes the exponent. 1/2 as an exponent means square root. So I get the natural log of the square root of the absolute value of x squared plus 1, then plus c. So that's what I'm looking for. All right. I'm going to go ahead and do number 5 in the notes now. So number 5, the integral of x squared over x cubed plus 2 dx. All right, so u is going to be my denominator, x cubed plus 2. Du dx would be 3x squared. So I have the integral. U is in the denominator. Again, what do I have left? X dx. I want that to match up exactly with what's going to be over here. So I'm going to do du equals 3x squared dx. It still doesn't match up exactly. I have to get rid of that 3. So I am going to divide each side by 3. So I get 1/3 du equals x squared dx. So now it does match up exactly. So I can go ahead and write this up now. So I'm going to get rid of the x squared dx and put in what x squared dx equals, which is 1/3 du. There's nothing left in the numerator now, so a 1 goes there. So that is typically what I like to see when I'm integrating. So I get 1/3, the integral of 1 over u du is the natural log of the absolute value of u plus c. Clean it up. That becomes the natural log of 1/3 becomes the exponent. 1/3 of an exponent becomes cube root of u. U is x cubed plus 2. Absolute value of that, all of that, plus c. So that's what I'm looking for. Alrighty. Skip on to number 8. Let me get a clean sheet of paper. So number 8 says the integral of 3x over 1 plus x squared dx. All right, so my denominator is going to be my u, 1 plus x squared, which means du dx is 2x, or du is 2x dx. My integral is going to have u in the denominator, and then again I want it to match, so I have 3 dx here. That's not what I have here. There's a couple different ways we can deal with this. 3 is a constant, so we can bring that out front. So I'm going to bring my 3 out front. Didn't get my black. Undo black. So I'm going to get my 3 out front. That's this 3 here. Then I want it to match up with what's over here. So what I then have left is now x dx because I brought the 3 out front. So that's this x dx here. I want to get rid of the 2. The way I'm going to do that is divide each side by 2. So I get 1/2 du equals x dx. So I can get rid of the x dx and put in 1/2 du. Nothing's left in the numerator, so I put a 1 there. All right. So what I now get out front is 3/2. The integral of 1 over u du is the natural log of the absolute value of u plus c. So now I can clean it up. So I'm going to get the natural log of the absolute value of u. U is 1 plus x squared to the 3/2 power plus c, which means the natural log of the square root of 1 plus x squared, that absolute value, cubed plus c is what I'm looking for. I will do more in the next video.